Hey, this is Dr. Corey Glenn with Blue Sky Bio, and I'm going to be showing in this video how to go about making a cast locator bar. Now, this is something that is not that difficult to learn how to do, and it can certainly save a lot of money if you can do this in-house as a dentist, or if you just have to outsource certain parts of the process. And so with this, what I'm going to show you is how to wax this pattern up, how to get everything ready, and then just delegate off the casting of it to a laboratory, which again will save you a lot of money in the overall process and give you a little more control in your results. And so one of the advantages to doing a bar overdenture as opposed to just individual locators is, as you can see on this model, I've got 3 implants, but by doing the bar, I can eliminate the rocking that 3 locators are prone to having by extending off the back of that with some distal extension. And so I can actually get more retention, I can get more stability with a bar overdenture than I can with just individual attachments. So what you're going to need to start the process is a verified cast, okay? You've got to make sure that this bar is going to be passive, so this has to be as accurate as possible. Now that can either be done by initially doing your master impression and then using a verification jig to verify it, or alternatively, what I usually would do is I would do a verification jig at the time of my master impression. And I did that by just making a floss web between all my impression fixtures, and then I would use Primo pattern or some type of a pattern resin to build a frame locking directly to my impression transfers all the way across them, so they're all connected. And then once that was cured, I would section those in between them, again, to release any shrinkage distortion that might have happened, and then just loop back together that small gap again. And this ensured a really passive verification jig, which I then would pick up in the master impression. So that helped me eliminate the appointment for a verification jig. Now, once you've got this really accurate master cast, you need to evaluate your prosthetic space. For a bar overdenture, you're going to be looking at 13 to 14 millimeters of space. So it's a little bit more of a space requirement than individual locators, which would be 9 to 10 usually. But again, if you've got the room for it, I do think this is a superior option because it is going to give more stability. So you could evaluate that in a couple of ways. Obviously, if you've got mounted casts, which these casts should be mounted, then you could simply just measure with a perio probe between the arches. Alternatively, if the patient has an existing denture that they're functioning with, and if that denture is pretty close to the intended end result, you could just do a suck down on that and then place it onto your model and measure through the suck down how much room you have down to your models, to your fixtures. So either of those options will work. Now the parts that you're going to need to start with some UCLA abutments. Now what I'm showing in this technique is how to make a cast locator bar, okay? This is not relevant if you're doing a milled bar. Milled bars are awesome, but they're obviously not something that any dentist is going to be able to do in-house. You'll have to delegate that out to a lab because that requires a very expensive mill. But you know, waxed and cast bars have worked forever, and so there's no reason why this won't work just fine if you do a good job at it. So when we're doing this, we're going to need some UCLA abutments. Now you've got to determine, are you going to do this bar at the implant level where it's attaching directly to implants, or are you going to maybe use multi-unit abutments? So let's say if you had set your implants up with angulations like an all-on-4 case might be, that's going to require using multi-unit abutments to upright them and to get everything to draw passively. Versus if you've got 3, 4 perfectly parallel implants, you might go straight to the implant level. Are you using a conical connection? That might mean that you don't want to go with something straight to the implant level that doesn't have that conical connection, like a non-engaging. So we've got to make the determination of engaging versus non-engaging. In the picture on the right, you can see these are plastic abutments, one engaging, one non-engaging. If you didn't have perfect parallelism, you're probably going to have to go with a non-engaging. And that opens up a little bit of a micro gap, and so you might want to maintain your bone better and use multi-unit abutments. So there's a lot of decisions that you can go into on this. Do you want to use a UCLA abutment that has a metal manufactured base to it so that you know the precision is right, versus one like I'm showing in the picture on the right, which is all plastic? The all plastic, is going to definitely be cheaper, but there's the possibility of a little bit of shrinkage, warpage during the lost wax casting. And so these are all determinations that you can make. In my case, for this demonstration, I'm just showing this with some plastic, non-engaging abutments, and these can be purchased on the Blue Sky Bio website for 39 bucks. I'm, in this case, demonstrating this on some Biomax implants, and so this was for the Biomax line. And this is what that part looks like when you order it. As you can see, it's just comes in a little silver package, and it's just a purely plastic cylinder that's going to go right down to the implant level. And then you're going to also need the cast 2 locators. Okay, so there's a number of options actually. You could use, drill a hole in your bar, tap it, and use thread-in locators. Now that's a nice option because if one day these wear out, you can back them out and just replace them. So they're a little easier to service in the long term. The cast 2 is a bit easier if you're just waxing your own pattern up in the office. And if you ever had to service this in the future, if those wear out, you can just grind this thing off and then replace them. Have the lab maybe use some of these laser centered locators, and they could just tack weld the locator right back into the bar. So there's ways to service these down the road if you have to, but in my case I'm using these cast 2 locators. They come mounted on a little handle, and as you can see in the well, here's the package of those. This is how they come in a 2-pack for $90, so basically $45 a piece. And if you look at these closely, you can see that right here, this is a little retentive portion. This is going to get embedded in your wax pattern so that when they do the burnout, this is going to get filled with metal back into this area, and that's what will embed this into the final bar. So the way we're going to start this process is by placing the UCLA abutments onto the implant analogs and then start directly waxing the bar pattern directly to that. Okay, now you'll do this either in wax or in pattern resin like GC pattern resin or Duralay, or you could use the product I like to use, which is Primo Pattern Gel. This is from Primotech. I like this because it's a lot faster to work with. It's just a light cured gel. So you would squirt this on, begin forming your bar, and it's just really quick to add to. I can make one of these bars in 20 minutes on a lunch break. It's very efficient to use using Primo Pattern. Now an alternative option is that you could also design the bar digitally and then 3D print that wax pattern in a castable resin. Okay, so that's what I'm going to actually show in this video. Know that you can do either one. Okay, both options work just fine. They get us to the same end result, but I like to mix in a little digital stuff. And so what I'm going to do is design this thing in Meshmixer and then print it in castable resin and then pick my UCLAs up inside of that. So if you're going to go that route, the first thing you're going to need to do is just scan your model with the UCLA abutments in place. Okay, so as you can see, I've used the Shining 3D scanner here. I'm scanning this, and that generates an STL model, which I can now bring into Meshmixer and design the bar in there, and that will eventually be printed, as you see right here. So let's jump over to Meshmixer and let me show you how I go about doing that. Okay, so I've scanned in the model that had the UCLA abutments on this, and I'm going to take a little bit different approach as to how I make the bar framework going across here. You could absolutely just do some spans of pattern resin across here and wax directly onto your model, making the resin pattern that you're going to cast. But I thought this would kind of be a cool option to do it in a 3D printed resin and just show you some of the functions there that can expedite this, make it a little cleaner. Anytime I can eliminate some lab work, I like to. So first thing I'm going to do is take my STL, and I always duplicate it just so that I've always got one as a baseline that I can come back to. So I'll turn that one off. Actually, let's turn this one on. We'll work off the copy. So what I'm going to do first is I'm going to take my select tool, and I'm going to select along the ridge the outline of what I want my bar to be. So I'm going to come straight across the ridge. And about right there is as far as I would want to extend any kind of a cantilever. I'm going to include all of these cylinders here, which is optional. We're going to end up cutting them out later, but for right now I'm just going to include them. to scale down my spot size, and I want this to encompass around each of the cylinders. So I'm going to make sure that it goes around each of them. And a little excess is better than not enough. So if in doubt, extend it a little farther, because it's very, very easy to just take a lab handpiece and grind this printed resin back after the fact. I find that to be a lot easier than adding resin. So we'll come around the back side here. And same here. And if you feel like you go a little too far, you can push the shift key and that turns it into an erase function. Alright, and so what I'm going to do here is I'm going to smooth the boundary. So come up here to modify and first optimize the boundary. That means if there's any little triangle that was left out, it'll pick that up, and then smooth the boundary. And now you can see this will give it a much more smooth contour for the next step that we're going to do. Alright, so with this still selected, come up to your edit menu and tell it to offset this surface. And what offset does is it just separates a new mesh off of the original of whatever we have highlighted, and it will set it off by whatever surface we put in, or whatever distance we put here in the offset. So right now it's at 0.3, which is actually what I want to use. And do you see the gap right here? It has offset all of that orange surface off by 0.3 from the original surface. And so we're going to accept that. Now it doesn't destroy the original underlying mesh, it just creates a new one. But now it's all still part of the same STL. Notice that there's not any new STLs over here. So with this still selected, come up here to your edit menu and tell it to separate it while it's selected orange like that. So now we have a new surface, okay? And you can see this surface right here. It is still just a one-dimensional skin though right now. This is not any kind of an object that you could print. So now that I've got that, I want to subtract out my cylinders. Okay, so what I'm going to do is come up and just use the select tool, and if you start it from somewhere out in this gray area and then circle, it just turns into a lasso tool. So if I click over here, I'm going to encircle this and delete it. And if you catch a little extra there, shift, undo that selection. Okay? And now we've got that. And now I want to go just a tiny bit more. So I'm going to start from inside that circle. And I'm just creating a little buffer space around this so that it has room for a path of draw to come on and off. Okay. And if it looks like it's a little too excessive, you could come to modify and contract the ring. That will pull it back by one triangle in all directions and then delete it. And same thing, contract and delete. So now I've gotten rid of all the little vestiges of the UCLA abutments. And at this point, we can now do an extrusion of this. Now, actually, there's probably one step we should do, and that is to smooth these holes to make this as smooth of a transition as possible. So let's clear that. Select tool, go down to a really, really small spot size, and just come in here and select right on the edge. That's going to select that whole thing, and then you can smooth the boundary and accept it and repeat the process. You'll have to clear it first. Once again, select an individual triangle, smooth it, and accept it. And accept. So here we go. And now, if I was to turn on the original model, you can see how that is extruding through, or here's the original model, you can see it a little better. So with that done, let's now select all of this surface. Now I could double click on it, but since I just created some new face groups by clicking on those, now I'm gonna have to come in and double click these others. What you can also do is hit just one little dot and then go to modify and select all, and all of this STL is gonna get selected, okay? And now let's T for transform, and let's give this some three-dimensional shape. Oops, wrong button, sorry. It should have been extrude. So go back with this selected, it's extrude. And that's in your edit menu. And let's go up a good bit with this. Okay. So what you're seeing is the initial bar shape beginning to take its shape. All right, so I will accept that. That's obviously way taller than we need, but that's okay. That's what I want. Now you want to look this over, and I have one little fold right here. So what I'm going to do is take my sculpting tool, the brush, low strength, smaller brush size, and I'm going to get rid of that little fold that you're seeing right here. And if it's being ornery and you can't get it, just select that little piece, circle it, and then erase and fill. Now you can accept that, and then you could smooth that out. I don't get too crazy with my smoothing at this point. I just want to get rid of any pieces of mesh that are crossed over one another like this. And once again, if there's a little piece that is not cooperating, I could just select that. And erase and fill it. Smooth it out. Okay. So hopefully you notice that the anatomy is following exactly with the ridge here. It's going to sit a perfect 0.3 over the top of the ridge. And the last thing we would need to do is make a plane cut on this. All right, so let's orient across here and then go to the edit menu and plane cut this to give a flat surface to our bar. And you don't have the ability to measure while you're using this tool, so I'm just eyeballing it, and I want to be able to make sure that I keep 2 to 3 millimeters of thickness to this bar in all dimensions. All right, that at least appears to have that. And if I accept it, I could go into the analysis tools and measure. And now when I click here, I've got this type of a measurement tool selected. If I click right there, which I think was probably the thinnest area, maybe right over here, that looks like 3 millimeters. Right here is 2.6, 2.8, measuring all around 2.5. I've pretty consistently got 2.5 to 3 millimeters of thickness all over this thing. So that's acceptable for what I'm going to do. Okay. The last thing that you could do if you wanted to do it is that you could go ahead and make your little slots to sink in the bar locators. And so if I wanted to, I could just grab some stock shapes here. I measured the nib of the wax in locators to be 2.5 millimeters. So I'm going to grab a cylinder, and when I pull this in, I just drop it into blank space over here, but it's a huge shape. If I wanted a cylinder that is, let's say, 0.5 millimeter bigger than that, so let's make it 3 millimeters, then I could just type in here with uniform scaling turned on, 3 millimeters. And now you see that I get this tiny little cylinder, which I can then pull over and position. And what's going to happen is that I'm going to end up subtracting out a little portion for that locator bar to sit inside of this. Okay, so what I want to do is get this thing as ideally positioned as possible to the ridge, because I'm going to make all of these things parallel. And I'm setting the path of draw of my bar right now of how it's going to go onto the locators. Okay, so I've got this here. I'm going to sink this down. It's only 2.5 deep. That's probably good. I'll sink it to about right there. Accept it, and then edit and duplicate it. Now push T for transform. This is how you maintain your parallelism of all these. Don't grab any of the rotation sliders. Just grab the triangle here that's in the middle and pull it over to the next place you want your locator. Accept that, duplicate it, T for transform, and repeat. Accept, and then one more time, T for transform, pull it back. So as you can see, we're going from 3 implants, and we're extending back a distal extension on this, and we're going to have 4 locators on our bar. Okay, and if you're worried about any of these not being deep enough, remember you can grab any of the straight sliders. Just don't hit the rotational sliders, because then you lose your parallelism. All right. And so I've got this surface. I need to first select the bar, and then hold Control and select one of those and hit Boolean difference. We can uncheck auto reduce result and then accept it, and then repeat. Control select, Boolean difference, uncheck auto reduce result, and accept it. I'm going to repeat. And what this does is it just gives me a little well that I'm going to be able to drop in the cylinder. Now what's going to happen is I'm going to now save this shape. Okay, so it's in its final form here. One thing I could do is I could double click on all this blue surface we extruded, and just clicking that face group I could hit modify and smooth to give this a little smoother contour. Now accept that, so it's a little bit smoother now. Now I'm ready to export this. So I'm going to go to Export Data, and we're going to put this in the folder where I'm keeping track of this. This is in my tutorials folder. Here we go. And this is UCLA Locator bar, and we're going to call this bar to be printed. And one thing I should have done prior to exporting it is run an analysis and an inspector. And if this threw up any holes, I would need to fix those and then export it again to export the repaired one. So now what I'm going to do is I'm going to print this object. Okay, so you saw the object that I designed in Meshmixer, and what I've now done is I've printed that in castable resin. I just printed up a couple of them because it's so small, it's a negligible cost in resin. You know, you could have just as easily waxed this up by hand. This just saved me some work, and by creating these little pickup holes for the Locator cast 2 abutments that I've made, this is going to enable those to sit in here perfectly parallel. You know, I would have just had to have done that by hand, but you can absolutely do this by hand if you want. It's totally up to you. If you've got the access to a 3D printer, then do that. If you don't, then I would suggest getting some of this stuff. This is called Primo pattern, and this is what I'm going to use to pick up the UCLA abutments as well as the cast 2 abutments. It's a castable resin which is light cured, and that light cured makes this a lot more convenient to use than the salt and pepper traditional stuff. But what I'll do is I'll take a coffee straw, the little thin coffee straw in a white color, and I'll just stick this tip into the coffee straw and inject it full of that, and then light cure along the whole length of the coffee straw, and then take a scalpel, slit that, and then when you open it up you're left with this, and it's a big long rod of castable resin. And now if you needed to, you could cut that into sections and lay them across here for every place that you're doing that, and that gives you a framework from which to work and then continue adding more resin. So lots of different ways that you can go here. I did just want to mention that though. Same process. If you're going to do this by hand, just take some spans of this, put it across here, and then just shape your bar directly out of Primo pattern right on top of your model here. Obviously lock it around here on your UCLA abutments and cure it, and then lock in your cast 2 locators here as well. All right, so I'm not going to do that. I'm going to use the 3D printed object that I've used, and again, that was just nice because it enabled me to set up my shape beforehand. It allowed me to control the thickness everywhere of where I was, and to make those pickup holes for the cast 2 locators. So what we'll begin doing now is just using some Primo pattern to pick this bar up. So I'm going to make sure that I'm sitting flush everywhere on my model, and I'm going to just place Primo pattern directly in this gap and begin picking this up. Okay, and then we'll light cure that. I forget the exact time you're supposed to cure this, but I always do just short cure times initially, and then when I'm all done, I will give it its final cure and make sure everything is really, really hard. Alright, so we've got one of those picked up. We could now take some more Primo pattern and squirt in the gap between our printed frame and the UCLA abutment. Alright. And again, even though these are dissimilar materials, they're both castable resins, and so you'll be able to simply pass this off to your lab to invest, and then they will cast this object all together. Okay, so now my cylinders have been picked up. We're obviously going to have to come back a little bit later and cut off the excess cylinder height. So know that I'm going to do that a little bit later. But now, before I go unscrewing anything, I want to go ahead and pick up my 4 cast 2 locators. So again, this is just a little trick that I did where I made the wells to accommodate that bottom portion of that. So I'm going to fill it up most of the way, and then just take the cast 2 locator, press it in to the hole, make sure it's sitting nice and flush, and then cure it. And these little black things that you're seeing, those are just the pieces that snap onto the top to give you something to hold on to these, because they're little bitty things. Alright, that's one. Take our next one, press in to the hole. There we go. Now the way this whole process works is that when the lab takes this final object, it's just going to be one big piece of resin with the implant connections also being in castable, in this case plastic, those little white cylinders. But then these metal objects, the locators, are going to be metal. So obviously they're not going to burn out, but do you see how there's this retentive shape to them? I don't know how well you can see that. That retentive shape, when they burn all of this out, it's going to leave a void, and the metal is going to get cast in and around that, and that retentive shape is going to embed that inside of the metal. So from your purposes, it will all be one single piece once it's been cast and divested. Alright, and just making sure that I'm holding everything in parallel. Okay, and this is our completed bar. You can see here, if I was to peel that off, that the locators are now embedded into this bar. And all that I need to do now is unscrew this and look on the underside and any little gaps that may have been left. Let's set these screws aside here as well. Any little gaps that may be left between the UCLA cylinder and our printed bar, we would just go back and fill those in. And then finally go and chop off the tops of these cylinders where they're sticking out excessively. And then this would be ready to send for casting. And you can send this to whatever lab you want. If you've got a local lab that does a nice job at casting, they can do that. The one thing you want to make sure of when you have them do the casting is that you need to send your master model and they need to do a passivity test. So hopefully you would have a soft tissue model, which I don't here, but they would be able to take that soft tissue model off, and you've got your verified impression model. They would be able to now take this and seat it on here, because what they're verifying for is they're making sure that in the casting process that nothing warped. And if they can't seat this thing down with just a single screw and make sure everything is seated, then what would need to happen is they would need to section it, just like a non-passive bridge or something. Section it and then laser weld it back together. So I would send to a lab that has that capability, or solder it together. I would rather have it laser welded. But that way they can ensure on their end that everything is sitting passively, and that would really complete the process. And so now you would have your locator bar, and you've been able to go from 3 implants out to a much more stable bar with 4 perfectly parallel locators, and really extended a lot farther back. So this will be a far more stable denture than what would have been able to be achieved if you had just done 3 individual locators. That denture still would have had a lot of anterior posterior rock, and you would have worn through attachments at a far greater rate too. So I hope this was helpful. It's pretty basic lab work stuff, and it's a mix of the digital and the analog, or pure analog, but being able to do some of this basic lab work can really save you a significant amount of money in your lab work cases, which is always important on these big cases. Reimbursement and everything being driven down as much as it is, you need to find ways to really be efficient with this stuff, and this really does not take a lot of time. So again, hope you found that helpful.